Hello folks, welcome to Netcruzer RC. This is going to be another Tamiya Tuesday and an update on the Tamiya TA07 Pro car that I'm building. So as you saw last time I did the unboxing, I showed you all the parts, and I'm in a bit of a rush to get this finished because I do want to start racing it immediately. Let me just show you how far I've gotten so far. I'm just starting the first steps of the TA07 Pro build, and I've got a bunch of my parts all cut out, and I'm on step one. It starts with the A-arms. I am using the optional TRF 419 carbon reinforced A-arms instead of the ones that came with it, but all the rest of the mounting is the same. It's interesting how it mounts up because it uses these kind of pivot balls on the end, and that gives you some tuning options. So instead of it being just a pin that goes into a hole, it's more of a ball cup socket so that you can buy optional sizes and offsets, so that'll give you your toe in and toe out for the rear depending on what sizing you go for, as well as you can do similar adjustments on the front for sweep, because each of these blocks has a number on it or an alphanumeric code, and that tells you what the offsets are. And there's a whole calculation that you can do to try and get the proper setup. For these A-arms, for the rears, you have to grease these balls and then put the blocks in. These are the blocks that it comes with, and they're plastic. You can buy optional aluminum ones. It supports a few of the different types. The mounting points on the chassis, it's got the triple, so you can put in a full right-angled TRF 419 style block. Or you can use these split blocks. Or alternative variants. And then for this side, it's the full-size block. It's a bit of a mix, but anyway, it's a unique chassis. So the rear arms are on, and I must say that they're a little sticky. Like, I would have hoped that they would be free-flowing more than that. I can't get them loosened up. It's not that the arms need to be reamed out, because the arms on the pins themselves are really loose, but once you get it installed into the blocks, it does bind up a little bit. Like, anyway, that's how the rear is. For the front, it's a little bit different. The front does not use those balls. It's just rods that jam into the mounts. So I'm about to install those now. There is something interesting in the book where it shows you putting an M13 and an M11 spacer, but then if you look over here it says, oh, by the way, use M12 and BA6 in place if M11 doesn't allow it to run smooth. So I'm choosing to build it out like this because this is a metal piece, and I'm assuming it's going to be slightly less shimmed than having the two big plastic ones on, and it should be a little bit more free flowing. So I'm going to install them that way, and I'll show you when they're done. All right, that's what I was hoping for. You see how much floppier these ones are? That's how you want your arms to be, where there's almost no resistance. That's using the metal spacer instead of the two plastics. So I'm happy with how the front is nice and loose, but the rear, you know, the rear, it shouldn't be that binding. I could try running a slightly less plastic spacers, I guess. I fixed up the binding problem with the rear suspension, and I did change out the plastic bushing. So it says to put two A1s. Since I chose on this side to use the M12 and a BA6, I had the M11s that I didn't use. So I decided to put the M11 on the rear in replacement of the A1, and that has completely fixed and made the rear suspension nice and loose, just like the front, with still fairly minimal play. That allows you to have the most efficient suspension available. Things are coming together nicely with the TA07, and there's the chassis and the drivetrain installed so far, and now I'm on to making the diffs. And one of the first things you need to do is break out all the gears. So that is where all of these white gears are from, and that's from these trees here. All of the gears, all of the cross members, everything has to be taken off manually off of these trees, and then you want to make sure that you actually strip off all the excess burrs. So that's what I was doing here. They do tell you to do that, although it's not very clear. They tell you to make sure you're removing any of the excess Also, when I look at this diff installation, how it's built, it looks to me almost exactly the same as the TRF 419. There's only a couple small little differences. The actual outdrives themselves are steel instead of lightweight aluminum, or they're, I don't know, they're a little bit heavier, but the differential joint is not the TRF differential output joint, but these are still really nice, high quality pieces. You do get the red gaskets, green seals, a bunch of shims, some microscopic screws here, and I believe it's actually bushings that they use inside of the diff. So that's one downside, is that it's showing that you want to install these bushings, BB12. One other last thing before I start assembling them is I am likely going to do a lightweight one in the rear, and I'm thinking going really thick in the front. And the way that these cases go together, they are keyed where you see up at the top there, maybe you can't. There, here you go. You see that indicator up at the top right here? That little divot, that has to align with the one on the back, or else you won't be able to get your diff cup closed. I'm going to take a silver Sharpie and mark the alignment points, because that's going to be really hard to see when it's full of grease and I'm trying to sandwich it all back together in this final step, which is to make sure that you align those two little markings. That's going to be a little bit tricky. These cross pins are particularly difficult to get installed properly. You have to use this little cutout in the diff cup in order to get enough room to get it to slide down in there, lined up with a small little pincher, and get it slipped in. Now I have the diffs built, and I'm just waiting for the air bubbles to get out. So I have rotated them to agitate all the oxygen in there and try and get the bubbles out. This one is my super thick diff. I'm going to put that one in the front. I chose to put in some 125,000 weight diff oil, and in the rear I just put in the Tamiya damper oil, which is what they recommend, to use damper oil in the diffs. But so I'm going to have my rear be the damper oil, which will be a loose diff, and the front will be 125,000 or a limited slip front end. Should perform better on the track. Okay, the diffs are done. I have them installed here in the chassis, so I've got the bearings on. Anyway, it's time to start fitting the belt, but here's how the chassis looks so far. Low friction belt installed. Diffs are done, belts installed, bulkheads are on, and that's it. That's steps A and steps B done. And now we're on to section C, but I'm going to do that another night. So it's time to start building the steering turnbuckles, and then some of the support bracing, and onto the axles. I'm working on the axles, and there's one very interesting thing about the rear ones. Overall, the axles are fairly normal. I have the fronts actually done and installed, but I'm working on the rears, and it's this rear pivot ball where this is an adjustment for your roll center, but you build it yourself. Normally this would just be a standard ball socket with a washer, but this is, you build it yourself. You have to take this Allen key and screw it into the top of this ball cup, and then you put a washer underneath it, so you're making your own ball end. I just think that's really weird. I guess it gives you more adjustability so that you can raise and lower it while retaining a lot of thread into the carrier. Like, that seems like it's a TRF racing spec thing that they would have come up with, because I've never seen that before. Interesting, cool. Working on building out the shocks and building out the shafts. A lot of C-clips. These are the things that I hate the most in all of RC, is getting these on and off. I think so. It's one of my biggest pet peeves anyway, these little clips. I really prefer shocks that don't use them, but a lot of 10 scales do. So I've got the first one pressed on by just pressing down on the table. Then you throw on the piston and then press the other one in, and I've been using my circlips again to try and clip them on, and it's been working okay. I've heard that Tamiya shocks are extremely smooth, and I think that their pistons are a big reason why, because man, this is a nice piston. It's noticeable that it's very well manufactured when you touch it compared to all the other ones that I've built, and I think that's a big reason why the Tamiya shocks are smooth. I'm working on the shocks, and I just have one left to build. I've got it, I have them bubbling out here. I just gotta add the fill. Interesting thing about the shock caps for these is there are two-piece designs. mount is plastic, so it sits inside the cap. So make sure you trim out this piece nicely, because it ends up being your shock cap. And one thing I wanted to note about when building these is if you follow the instructions, they want you to put the cap on when the piston is all the way down at the bottom. If you do that, you will get 100% rebound, and I don't want that. So I built them with very little rebound, like 0 to 10% rebound is what I was going for, and they're pretty good. So how to do that is you screw the cap on when the piston is all the way near the top. Now there's a little trick to it where you want to put the bladder on, it'll squeeze out some more oil, pull down the rod, the suction will hold the bladder in place, wipe around the outside, and then while you're slowly threading the cap on, raise the piston, and so that the piston is near the top just as you're fully closing it, and then you'll wind up with as little air as possible and as little rebound as this. One other thing about these shocks is they do feel incredibly smooth. Part of that is all about that piston. This is what you get in the low-end kits. If you were just to use a shock piston, that's what it is. And it's got a flat spot, it's got a lot of manufacturing marks. That makes a huge difference. I mean, even to get a Tamiya with oil-filled shocks in the base kit is rare, but when you're using these higher-end shocks, having that really nice machined Delrin or low friction piston is noticeable. Okay, this Tamiya servo saver thing is really cool. So it's this plastic outer, you pick the spline that fits your servo, then you've got the horn and the outer protector, but this is the servo saver system, which is 3 pieces of metal spring, and they all wedge in on top of over each other. The 2 gold ones are actually the same size, so the one in the middle is really hard to get on, and then the outer one is black. And that is really cool. I've never seen a servo saver use that type of spring design, and that is fairly ingenious, and it looks really, really well built once you put it together. Really tough, so I like that a lot. Anyway, so building that out. The chassis has the springs on. It's a nice looking build with the white springs and the white belt. That looks super cool. Yeah, so pretty happy with it so far. It's a blingin' car. You can get it even more so if you keep adding more of these blue bits over time. Right on, so there's my chassis with the suspension installed. And here it is. It is finished. I finished this in 1 week, so I think I started on Monday and now it's Saturday, and I'm going to be racing it tomorrow, so I wanted to get some beauty shots of it and show you what it's like before it's ever been run. But here it is, completed. As I showed you before, it's got this really neat exo cage design to it, and I'm pretty happy with how it's turned out. I pulled out all of my old electronics. I ended up building this for USGT. I know I originally said I was going to build it for 17.5, but as I was building it, I realized that this chassis is best suited for USGT, so that's the electronics I put in it. Let me grab the camera and I'll show you a bit more. So what we have inside here is a 21.5 turn stock spec motor, Aries Pro by Sky RC, an old LRP ESC, a Traxxas receiver, some old high-tech servo that I have. I basically recycled all my electronics. So I had the motor, had the ESC, had the receiver, had the servo. I just put everything in it that I had laying around that wasn't being used much anymore. I didn't really buy anything for this except for the kit. The tires I already had. These are the USGT spec tires. They are used 1 season. As you can see, this side's a little bit worn, but it might be just need to be cleaned. I'm liking the car so far. It's really neat. I've set up my spot here for my transponder. Transponder is very important for racing, so this is going to live up here, and I don't have a transponder for each car, so I'm just gonna, you know, plug it in and then move it from car to car as needed. And I did decide to run this, which is a bit of an air scoop. It's completely optional. It just comes on and off by these 2 screws up here, and this plate can come off. I'll run it like this for now. I don't know, it gives it kind of a unique look. There is another part that I chose not to put on, which completely changes the look of the car. Right now I am not running the gear cover. If you do, it completely changes how the car looks. So let me grab that and I'll show you. Here's all the spares that I have for the car. So because I put on the upgraded R belt, this white belt is the one from the TA07 R, as well as all of these upper chassis deck pieces are all carbon reinforced from the R, as well as I put in this aluminum pulley, this one. So here's the stock belt. Here's all of the extra parts that I have that I would want to carry around as spares. Here's the original A-arms that are softer, some big plastic bits. These are not even for this car, but came with it. But this is the gear cover, and when you install this, it completely changes the look of the car. It makes it look very plasticky. I mean, it is a very plastic car, but once that's on there, it covers up all the cool gearing and pulleys and all the fun stuff. It just bolts on by these two screws here on the side. So all you have to do is loosen those and it just pulls right off. But there is an idler in it. This is a bearing on the inside. There's an idler, which is for tensioning the belt. But when the motor is all the way back, I really don't think you need it because it applies pressure right here, just a little bit. If the motor was in the middle or front position, I think it would be important to be running this cover as an idler, because you're going to have a long span of belt that's got to go from here all the way to the back. I chose to put the motor in the very back position because if you don't, if you want to move it to the middle or forward, you really run out of a spot for your electronics. With the motor in the all the way rear position, I still barely had enough room to get my ESC, all my wiring, my sensor cable, my antenna, my servo, and everything is all crammed in here. A cat pack is tucked in under here. This braided wire is the sensor cable. You can maybe see the capacitor in there somewhere. It's hiding, because you want to make sure you're not touching the belt. You have to give it clearance for the belt, so everything's a little tight in there. If the motor was moved one forward or all the way to the front, there is an optional piece that you're going to have to install, which is this plate, and this plate sits here. It gives you an optional spot to mount electronics, and that sits on top of the battery. The battery slips in underneath. The battery system that I'm using is going to go for lightweight, 3800 milliamp hours, 35C, bullet plugs, and it just mounts in just like this. And at first I was thinking it's not going to work because once you get it into position, the positive fits in fine, but the negative is very hard to get in. So all you do is just slide it out halfway, loop this under here. There's just enough room where you can plug it in, and then you can plug in your, that's if you have high bullets, because and the battery has to be in this type of position because the way the frame kicks up, it gives you just enough room where it's not putting too much stress on that wire, where it can fit in there just fine. On the front, you definitely can't have your bullets on the front. It just will not fit. And then to secure the battery is this piece, and it slips in under here and then secures with a pin. So let me just show you that it is operational. So that's the high-tech servo that I have. It's a little slow, but it's torquey. You should be fine. Yeah, so it is operational, and I'm going to be racing it tomorrow. So that's the chassis done, and I think I'm just going to leave it at that for now. So yeah, you know, you're not going to get to see what body I chose to run on it this week. I am going to take it racing tomorrow, and then I'll come back with an updated report of what body I decided to put on this thing. You'll see what it's going to look like for this Build Off 5, and then I'll show you some racing footage of it next week. So this is it for now. If you enjoyed this, hit that like button. If you're new around here, subscribe. If you want to talk to me, leave a comment down below. And as always, thanks for watching.